The reasoning behind the wiring CN1 JST port. In my original concept, I targeted the P5 port, GPIO 1 and 3. Changing this to the CN1 JST connector, GPIO 22 and 27, is what fixed any problems that I was experiencing. The wiring scheme: CN1 port bypass, GPSTX to keep GPIO 22, assigned to hardware serial 2RX. GPSRX to keep GPIO 27, assigned to hardware serial 2TX. The reasoning for moving away from the P5 port, GPIO 1 and 3, was to completely eliminate hardware conflicts with the onboard USB to serial chip during code flashing and debugging. Further details regarding ports and conflicts are towards the end of this video. Some details of the program. The software libraries used are TFT_ESPI, display management, and TinyGPS++, NMEA sentence processing engine. Current unit profile, pure metric system. Speed in kilometers per hour, altitude in meters. The problem with GPIO 1 and 3, these pins are tied directly to the ESP32 serial 0 peripheral. On the keyboard, they are physically hardwired to the onboard CH340 or CP2102 USB to serial converter chip. When you connect your computer via the USB port to upload code or check the serial monitor, your computer uses these exact pins. If the NEO-6M GPS module is also wired to GPIO 1 and 3, both the GPS module and the USB chip will try to drive the same electrical lines at the same time. This results in data collision, corrupted NMEA sentences, failed code uploads, and system crashes. The CN1 JST connector breaks out GPIO 22 and GPIO 27. These pins are entirely unassigned to any vital onboard system, leaving them 100% free to act as dedicated communication lines. Utilizing hardware UART instead of software emulation. The ESP32 chip has 3 built-in hardware UART controllers: Serial 0, Serial 1, and Serial 2. Unlike older boards like the Arduino Uno, the ESP32 features a pin matrix multiplexer. This allows you to assign almost any internal hardware serial controller to any free external GPIO pins. By using hardware serial GPS serial 2 and mapping it to GPIO 22 and 27, I am utilizing the chip's dedicated internal silicon hardware to handle the incoming serial data stream. This operates independently of the CPU, preventing timing issues and data loss that often occur with resource-heavy emulation options like software serial.